Hello, today we start working with complex number. To motivate our work, we start by considering a fairly familiar situation for us. Let's say we want to solve the equation x squared plus 1 is equal to 0. We know that we are trying to find a value of x such that it's equal to either plus or minus the square root of minus 1. But since we cannot find square roots of negative numbers in the real numbers, we know that this, whatever it is not a real number. What we know about this mysterious number that is not a real number is that if we multiply it by itself, the result is minus 1. Well, it turns out that even though so far we have said, oh, we cannot solve this, we actually can solve it if we consider a new set of numbers that we denote with C, and we call the complex numbers. Complex numbers. These numbers, they include the set of real numbers, so the set of real numbers is inside the set of complex numbers, and this mysterious value minus square root of minus 1 is one of the numbers we're going to consider. It is just a notation to call this number minus square root of 1 by the letter small I, and we are going to follow that notation. Now, let's say that more in general, we are trying to solve any quadratic equation. So a squared plus bx plus c is equal to 0. We have a formula to solve this. We have the quadratic formula. So we know that the solutions to this are given by minus b plus or minus, and then we have square root of b squared minus 4ac. All of that under the square root, and then all of this divided by 2a. We run into trouble when what we have over here under the square root is not positive or 0. So if this is negative, then we say that we have no solution in the set of real numbers. But what do we do then? So let's say we have that b squared minus 4ac, so the discriminant is less than 0. Then what we do is to rewrite this as the number minus 1 multiplying, and then we change the signs inside, so minus b squared plus 4ac. So now this second factor we have over here is positive. We change the sign for that. So when we try to take the square root of that, so we have the square root of minus 1 multiplied by now a positive number, we can write this as the product of two square roots, the square root of minus 1 multiplied by the square root of minus b squared plus 4ac. Now, there is nothing special about the second square root we have. This is the square root of a positive number, so it's a positive number. And then what we have over here is the complex number I that we defined before. So what this means is that now we are able, if we consider this new set of numbers, we are able to find the solution of any quadratic equation because it's going to be given by minus b and then plus or minus this number I multiplying square root where we don't have any problem because it's the square root of a positive number, and all of that divided by 2a. So now this 2 actually, because we have potentially plus minus, this belongs to a set of complex numbers. Note here that we started just by considering the solution to one quadratic equation we didn't know how to solve, so x squared plus 1 is equal to 0, and we added one number, we introduced a new number, the number I, that is the square root of minus 1, and by introducing that number, we can actually now find the solution to any quadratic equation. So it's enough to introduce one number that came from the solution of one particular quadratic equation, and now we are able to solve any quadratic equation in the world. So we want to see what exactly is in this new set C of numbers, the complex numbers. So what we have over here is all the numbers of the form a plus bi, where both a and b are real numbers, so nothing new over there, and I is the square root of -1. So all the complex numbers that can be written of this form are all the numbers of the form, we call them complex numbers. The a, so just the real number that we are summoned to in this complex number, this is what we call the real part. And the number that is multiplying I, so the b over here, is the imaginary part. It could be that b is equal to 0. That's one possibility. In that case, we just get the number a, that is a real number. It could also be that the number a is equal to 0. So in that case, we will have b multiplying by I, and this is an imaginary, this is a number that only has the imaginary part, and we call it pure complex sometimes. So our next goal is to see how do we actually operate and what are the operations we are allowed to do with this set of complex numbers. First of all, we are going to look at what happens when we multiply I by itself. So we are doing I times I, so this means we are doing the square root of -1 times the square root of -1, and we define this exactly to be the value -1. Now let's say that I want to multiply I by I by I, so we are doing over here, we did first I squared and got -1, we are now doing I cubed. So we are getting -1 from the first two factors, and then we are multiplying this by I, so we are getting -I. If we try to multiply I by itself 4 times, so that means we are doing the 3 first powers is -I, and then we are multiplying this by I, so we are getting -I squared, which is -1. So this is equal to 1. And of course, I could have written first of all I to the power of 1 itself, which is I. Now, this cycle of I minus 1 minus I 1 repeats. If I try to do I to the power of 5, then that's going to be I to the power of 4 multiplied by I. So it's 1 multiplied by I, so this is just I. If I try to do I to the power of 6, that's going to be I to the power of 5 multiplied by I itself. So that's I multiplied by I, which is -1. So we're repeating the results. We got I when we do I to the power of 1 and I to the power of 5. We got -1 when we do I squared and I to the power of 6. If we keep going, the next power will give us -I, and the next one will give us I. So in general, we can write that we know what is I to the power of n, depending on what is n. So if n is, let's say, something multiplied by 4 plus 1, so it's a multiple of 4 plus 1, then this is going to give me just I. If it's a multiple of 4 plus 2, then the result is going to be -1. If it's a multiple of 4 plus 3, then the result is going to be -I. And if it's a multiple of 4, finally, so n is 4k, the result is going to be 1. So this is the result of considering all the possible powers of I.